Hey, students, we're going to be looking at average atomic masses and how they are calculated, and it's really not all that scary. But you will need a calculator. Be sure you have one. I have mine right here, and you don't want to do these calculations by hand. So be sure you're prepared. You already went over a lesson of isotopes. Isotopes are atoms of the same element because they have the same number of protons, but they have different neutrons, and so they will have different masses. So same identity, different masses. Okay, it's like M&Ms. All M&Ms are M&Ms, but some of them are little tiny, and some of them have peanuts in them, and some of them have peanut butter in them, and all these other things that they now put in M&Ms. Okay, they're still all M&Ms, but they have definitely different masses based on what's inside of them. So atoms are very much the same way. Okay, we're going to look at how you calculate an average atomic mass. And I just want to start with a little bit of philosophy. Why do we need an average atomic mass? Okay, so I'm going to grab an annotation tool here and get that out of my way. There we go. Okay, so let's get a color. What color do you all want? I heard blue. So I'm going to go with blue here. Okay. So we got Homer, and if you know Homer Simpson, he's not the brightest person in the entire show, honestly. He's probably one of the least bright in the entire show. So he's going through school, and if you know, he has no clue what he's doing in his job, and it's probably because he shared all his answers with friends to make sure they all got the correct answers on their assignments, which is fine. They got 100% on the assignments, but he would not do well on his summative assessments on his tests. So he's like, okay, no big deal. If I make 100 on my formatives, even though I'm only making 40 on my summatives, they're going to average 140, averages to 70. And he's true, it does average to 70, but that's not how grades are calculated here in our district, right? So in KSD, we use a weighted average. That means that the amount that each assignment's worth changes. Formatives are worth 40, summatives are worth 60. Okay, so very similar to isotopes. They're the same thing. They're all schoolwork, but some are heavier than others. Some are weighted more than others. Get the vocabulary we're working with? Okay. It's always going to be calculated this way. Let me show you the form. I'm going to take the grade. So for formatives, it's 100. And I'm going to multiply it by the percentage. Okay. And I'm going to take the grade. So for the summatives, it was 40, and I'm going to multiply it by the percentage. Okay. That's all I'm doing. And you can have the little percent signs there if you want. Those don't really matter. Okay. So the grade, so this was for formatives. This was for summatives. Notice with two different types of grades, I had two different lines. Okay. So formatives, grade times percent, grade, summatives, grade times percent. Now I'm actually going to calculate this out. I know this ends up to be 40, okay? But I'm going to take my calculator. I'm going to go 40 times 60. Oh, you know what? I lost some zeros. My apologies. There we go. Okay, I have 4,000 and then 2,400. And wow, I don't know why my pen did that. My apologies. It is now entirely writing on its own. This is a little unnerving. Okay, so we're going to try this again. Ah, no, we're not. It's apparently not liking me. Okay. Anyway, I got these numbers. I wonder if I can undo the scribbles. Okay, let's try again. Here we go. 2,400. Please believe me, that's 2,400. And then we're going to add them up. Okay, so plus I'm going to add. So 6,400. Now, easy math, easy math. But here's the thing. I am doing a percentage. I multiplied, I got a number, I multiplied, got a number, I added, but I'm doing a percentage. The word percent literally means per is divide and cent is 100. So at the end, I still need to divide by 100. So you're going to divide by 100. Plug that into your calculator. 6,400 divided by 100, 64. I know, I'm sorry, my pen is having some issues here. Okay, so 64 is his actual grade. This is what would be showing up in Aries, not the 70 that he was looking for. He's failing. Okay. And that is one of the reasons that Keller weights their assignments as they do, so that you do have that emphasis on learning the material to do well on the tests. Okay. So that's the form we're going to do. Now, that's why we do it. Let's talk. I need to turn off my annotations real fast here. There we go. Oh, I need to clear my annotations. My apologies. Get rid of all my old annotations here. All right. In chemistry, we get isotopes for elements, atoms of the same element that have different masses. So the question becomes, what do we put down as the mass for an element? Well, chlorine is famous in that it only has two isotopes. Now, that should tell you something. If it only has two isotopes and it's famous for that, then it's probably telling you that a lot of the elements have a lot of isotopes. All right. But we're going to do an average for the mass of chlorine. And wouldn't it make sense to do a weighted average? Is it really fair to chlorine to say, oh, well, you've got mass of 35, you got mass of 37, your average is 36. Look at how much we have. Okay. And I know the numbers don't line up to the lines well, but look at what we've got. And I need a color. I heard green. Okay. Let's do this. Okay. We know it's not fair to say it's 36. There's a whole lot more 35 than there is 37. So it really would be more fair that the mass is closer to 35 and not as close to 37. So that's what we're going to do. And we're going to do it just like we did our weighted average for our grades. We're going to take the mass, 35, and we're going to multiply it by its percent abundance, its percentage. Now, I know the numbers don't line up well. I was working with a spreadsheet and it didn't paste into Word well, but that's a 75 mark there. So I'm going to take 35 times 75. And 35 times 75 is 2,625. And I'm trying my best to make my handwriting legible. There we go, 2,625. All right. And I have the mass of 37, so I'm going to write down 37. And I have the percent that was a 25. I'm going to have 25. And I'm going to grab my calculator. You don't want to do this by hand. I'm going to have 37 times 25. And that's 925. And I'm going to add those numbers up. And this you could easily do by hand, right? You just have to carry some numbers. It's all good. Wow. There we go. Okay. So we've got, just double checking my work. Yeah, I thought I carried one too many. There we go. So we've got 3,550. And again, we're working with percentages. We need to do one last step. We need to divide by 100. So when we divide by 100, we get 35.5. And that is definitely a much more fair weighted average for the mass of chlorine. Having it closer to the 35, farther from the 37, since there's more 35 and less 37. And this is actually literally, this is how those numbers get put on our periodic table. Scientists do all this calculation for every isotope of every element, and they find this weighted average and put that there. All right, so that's how we do it with chemistry. That's how we're going to do it with elements. And flip it over. You need to go to the back of your notes page. There we go. Here's two elements of carbon. Carbon has a lot more than two elements, but here I'm showing you two elements of carbon. And check out the percentages. Okay, now before I begin, I need a color. I heard pink. We're going to go pink. Okay, so check out these percentages. We have 98.93 of that kind, this kind being carbon 12. And we have 1.07 of this kind, carbon 13. And so, which one? Easy question. Should our average be closer to 12 or should our average be closer to 13? And if you're seeing how this is a huge, close to 100% number, that means there's a lot of carbon 12. Yes, there's a lot of carbon 12. So it should be closer to the carbon 12. Okay, it's that easy. That's all there is to it. Let's do this. Let's do the calculation. We're going to take 12 times the 98.93, and I'm going to take the 13 times the 1.07. And by the way, we're going to round to the hundredths place. And that's going to be good. And on tests, it will tell you very clearly. If you need to calculate a number, it will tell you very clearly where to round to. So be sure you're reading and paying attention. It will tell you right there in the question, round to the, okay? So I'm telling you now, we're going to round to the hundredths place. So I'm calculating the first one. And I get 1,187.16. And I'm going to calculate the second one. Wow, it helps if I hit the times button first. There we go. Okay. And I get 13.91. And now I'm going to add that up. And I could certainly do this by hand. I'm hoping it's going to be a little quicker to type it in my calculator so we can keep moving here. 1,201.07. Now, again, I use percentages, and percent means divide by 100, so I still need to divide by 100. So my final answer is 12.01. Now let's check our work. Is 12.01 closer to 12 than 13? Because we predicted it should be closer to 12 and not 13, and it is. Now check this out. Go look at carbon on the periodic table. We got 12.01. And on the periodic table, officially, it's 12.011. Now, there are more decimals if you look up a different periodic table. But look at how great we got. We got really, really close. This is how it is done. The mass times the percent, the mass times the percent, add up your numbers, divide by 100. That easy. 3 simple steps. You got this. All right. I'm going to clear away, and we're going to move on to some more examples. Helps if I get my cursor back. There we go. Okay. Oftentimes, we will get data in chart form, and we are expected to work with it in chart form. I actually like it in chart form. I'll show you why. Okay. But I need a color that we haven't used yet. Okay, I heard purple. So we're going to use purple. What do I do to find an average atomic mass? I'm going to take the mass times the percent. So check this out. I already have the mass. I have the percent. I'm just going to go, times sign there, times sign there. Mass, I'm going to use all those numbers times the percent, and it's going to equal something. Mass times the percent, it's going to equal something. Okay, so I'm going to grab my calculator. And again, at the end, I'm going to round to the hundredths place. 62.929 times 69.17. 4,352.7. Oh, it rounds up 0.80. Okay. And then I'm going to take the 64.928 and I'm going to multiply it by the 30.83. And I get 2001. Wow, that was a 2. 2001.73. And I'm going to add those up. So I'm going to type it in my calculator, hoping it speeds me up a little. I'm certain I could do that by hand. 6,354.53. And then again, we use percentage. Don't forget this last step. You got to divide by 100. Okay. Very last step all the time. Divide by 100. So when I divide by 100, what I'm going to get is, for my final answer, 63.55. There's my final answer. Now, let's check my work. Your answer should always be between the two numbers you've got. And it is. It's between those two numbers. So if that works. It also should be closer to the one you have more of. And I definitely have more 62.9, which is almost 63. And my answer is just a little above 63. So this looks really good. And if you go to the periodic table, you can see we're actually very, very close. I even check how close we are. Okay. We're only off by a little bit of rounding in that 10th place, which is really, or 100th place, sorry, which is really good for us. Okay, so this is how it works. This is how scientists did it. This is the technique. Again, same three steps: mass times the percent, add up, divide by 100. Those three steps. That's all you have to do. You just do them over and over again. Those three steps. Okay, I'm going to clear, and we're going to move on to my last example here. Now, this time, oftentimes in chemistry, we get it in words, and oh no, scary. There's words to go with our numbers. It's horrible. Okay, it's not horrible at all. I need a new color. Okay, I heard brown. And what I want to do is be certain, though, I get the masses with the percentages. So you might want to actually read through and like begin making connections. Okay, annotate the question, make some connections. Here's a percent. What's it go with? It goes with that mass. Here's a percent. What's it go with? It goes with that mass. Now, notice the percentages were first. That doesn't matter. Mass times percent or percent times mass, same thing. All right, multiplication, the order doesn't matter. Very valuable lessons you learn in math class. All right, so here we go. I'm going to take 78.99% and I'm going to multiply it by 23.985. And again, I'm going to take the percent times the mass. And I already made my annotation, so I know I'm not going to like confuse these. And that's the absolute important thing, is that you don't confuse, okay, 11.01. You don't confuse which percentage goes with which mass. Read carefully, slowly and carefully. You will figure it out. So mass times percent or percent times mass, all the same thing, doesn't matter the order. Definitely going to calculator this one. 78.99 times 23.985. And honestly, you should pause the video here and see if you can finish working it on your own and then restart the video to see if you got it right. Because that would be very helpful to know with this final example how well it's going for you. 1,894.58. I'm going to take 10 times that, which is actually pretty easy, 2,498.60. That is a technically rounding to the 100th place. If you're told to round to the 100th place, you do add the 0 in, just a reminder. And then 11.01 times 25.983. And I get 2,800, no, sorry. I need to back up a moment. Where's my eraser? Okay, I'm going to check my work in the calculator, be sure I typed it in correctly. I did. Okay. So I get 286.07. Okay. So there we go. Which makes me realize I have the wrong number in the middle. Ah, my apologies. I'm so very sorry. I should erase it all. Here we go, erasing it all. Okay, my apologies. I moved the decimal too many times. You shouldn't do that. It's not a good thing. Okay, so here we go. Can I have my pen back? Thank you. This should be 249.86 because 10 is only moving it by 1. Yeah, okay. This one I still believe is correct. So now we're good to go. My apologies for that mistake. The way I caught it was realizing some decimal sense. There's only, like, multiplying by 10 only moves it by 1 decimal point. Should not have moved it by 2. That was my bad. Okay, I'm definitely going to run this all through the calculator. 1,894.58 plus, look, I'm letting the calculator do the work. 249.86 plus 286.07. Just letting the calculator do the work. I get 2,430.51. And then last step, right, divide by 100. So my final answer is going to be 24.30. Now let's check our work. It should be between the highest and the lowest. So is 24 between 23 something and 25 something? It is. So I'm good to go there. Is it closer to the one I have the most of? Here's my mostest number. I know I kill English. It's okay. That number is the biggest number. So it should be really close to a 23.9 number. And yeah, 24.3 is pretty close to 23.9. Very, very close. So I do believe I did that all correctly now by double checking that work. So that's average atomic mass. That's how we calculate it. That's how scientists calculate it. You're going to run into a practice now, and you're going to just be doing this again. 3 simple steps. Mass times percent, mass times, just list them all out. Mass times percent, step 1. Step 2, add up all those subtotals after you do the mass times percent. And then step 3, divide by 100. Now, it should warn you if you forget this last step and you think your answer is 2,430, it should warn you by looking back at the numbers in the problem. That does not make sense. And then you go, oh, silly me, I didn't divide by 100. So if you forget, look at your answer and just double check your answer makes sense. All right, good luck on your assignment. That's average atomic mass.